This conference will now be recorded.
All right, this is a video for the brief cal covering some of the notes that we skipped over from the 1.2 to 1.4 packet. So make sure you watch the entire video. The first one is we skipped this word problem over. This was dealing with break-even points. So let's read through it and answer the parts. You are setting up a part-time business with an initial investment of $21,000. The unit cost of the product is $11.50, and the selling price of the product is $19.90. So we want to find the cost equation and the revenue equation. So the cost equation, which we usually denote as C of X, is related to money that has to be put forward for the startup of the business and making each item. So it's usually the item's price to cost per unit. So that's 1150X, because that stands for per unit, plus the 21,000, because that was their startup cost. The revenue function is how much money they bring in every time they sell an item. So that's $19.90 per item. The break-even point is when cost equals revenue. So when we set those two functions equal to each other, it's 1150x plus 21,000 equals 1990x. We'll subtract the 1150 over with the x to get both of our x's on the same side. So that's going to be 21,000 equals, that would be 840x. And we'll divide by 840 to see the number of units that it will take for them to sell to break even. So let me get my calculator pulled up. So 21,000 divided by 8.4. That's going to be 2,500 units. Okay, part C says how many units would it take to yield a profit of 1,000? So to know that, you have to know the profit function. The profit function, P of X, is the cost function, said that backwards, the revenue function minus the cost function, because you have to have more revenue than cost to make a profit. So if we plug in R of X, it's 1990X, and then it's minus the whole cost function. So you want to put that in a parentheses, and you're going to distribute that negative. So this would be that the profit function is, let's see, 1990X minus 1150X minus 21,000. And that makes that P of X equals 840X minus 21,000. Okay, we want a profit of $1,000, so we're going to set P of X as 1,000. So we're saying that this is how much profit we want to have, of course, after the break-even point. So we would add the 21,000 over, so that makes this 22,000. And you might get a nasty answer sometimes when you're solving these problems, so we're going to talk about the rounding. To make the profit work, you have to round up, no matter if it rounds up naturally or not. Otherwise, you will not make that profit margin. So 22,000 divided by 8.4 would naturally be a 0, does not bump a 9 up, but because we want to make sure we hit the profit, we're going to bump that up to 2620. So 2,620 units. So we do round up irregardless of that actual decimal point value, because we want to make sure we don't undercut our profit of $1,000. We would rather overcut it and make more. Okay, so we skipped one of the equilibrium point problems. That was number 2 here. It says the demand and supply equation for a fitness tracking band are given by these functions. This is the demand equation, P equals 205 minus 4x, and P equals 135 plus 3x is the supply equation. Remember, P is the price in dollars, and X represents the number of units in thousands here. I don't believe on, yeah, so we didn't write million units on the one in class here. I did not notice that when we were doing it, since we were trying to catch up. So you'll want to go back on your notes for number 1 and make sure you put million units instead of just units. So let's solve this one, and we'll talk about how it's just writing the words in at the end. So when you do the equilibrium point, you want to do 205 minus 4x equals 135 plus 3x. You want to set supply and demand equal to each other. We're going to add over the 4x. So that would make that a 7x over here. We're going to subtract the 135. So that's going to be 70 equals 7x. So that's going to be divided by 7, and that's going to be x equals 10. So now you know why that one that we did in class, it didn't seem like it was a big deal. It's because we forgot to put the millions. So this is actually, you can either write 10,000 with the word, or you can write 10,000. So the units is 10,000 units. So you could either do it that way or this way. And then we're going to plug that in to find the price for the equilibrium point. And I would plug it in as you solved it. So it's going to be still that, it's going to be just the 10. So this is 205 minus 40. Otherwise it would be super large. So this is $165 per unit. So if you think about that as an ordered pair, it'd be 10,165, which they probably would still write as 10 for graphing purposes, and just number on their number line, they would count by thousands. They would actually mark that that was counting by thousands. But it's 10,000 units and $165. Okay, so we did 3, and that ends up that section. I believe we skipped a couple of problems in 1.3, so I'm going to try to go and hit those real quick. We did not do, I believe, number 1. This is another find the equation of the line with the given characteristics. So we're using our point slope formula since we have a point and a slope. So y minus negative y would be negative 2 would be y plus 2 equals negative 4x minus a negative 1. So that's going to be x plus 1. And if we're going to slope-intercept, it's pretty clear. We just distribute and subtract the 2 over. So that's going to be negative 4x minus 6. So there's that equation. Okay, I believe there were a couple other ones we didn't do. This one has a slope of 0. If you know that right away, means it's going to be a horizontal line. You could just go ahead and write y equals 7 because that's the y coordinate. Or you can do it by point slope here and see that 0, when it gets distributed, completely cancels out everything on that side. So then you add the 7 over. We did 5 together, and we talked about 4 and 6. So I believe we did both word problems in class. That leaves us with section 1.4. We skipped over just a little bit at the end of this section, evaluating a function. Now, number 2 is a little more difficult. I'm going to do it on the video tonight, but I'm also going to do another one of those in class together so that we're good on that, but I am going to work through these. So for evaluating a function, this is really just plugging something in for the x's and evaluating it out. So f of negative 2 is not f times negative 2. It means f evaluated at negative 2 for all of its x's. So this is negative 2 squared minus 3 times negative 2 plus 2. Negative 2 squared is 4. Negative 3 times negative 2 is positive 6. Bring down the plus 2. And that's going to be 10 plus 2, so that's going to be 12. What a lot of people don't realize is that that's an ordered pair you just found. That is negative 2 for x and 12 for y. But right now they're just asking us for the value. Okay, so then we're going to plug in this 1/2 next into the same function. So 1/2 squared, going up here for my function, minus 3 times 1/2 plus 2. 1/2 squared is 1/2 times 1/2, so that's 1/4. It's just squaring the top and the bottom. This is going to be negative 3 over 2 if we multiply those two together, plus 2. I would go ahead and get a common denominator for all 3 pieces, and 4 will work, so we need to times this by 2 over 2, and think about this one being over 1. So that's going to be minus 6 over 4, times this by 4 over 4, so that's plus 8 over 4. And then once all your denominators are the same, you can add and subtract across. So this is 1 minus 6, which is negative 5, plus 8, which would be 3, so 3/4. Now the very last one here is a little different because we're not plugging in a number, we're plugging in a binomial. And that does create some problems for us, especially with working out the algebra here. The biggest thing students do wrong is they just square the m and the 1 and say it's m squared plus 1. That is not correct. That rule of squaring everything inside only works if it's multiplication or division. So we have to FOIL this. So this is m plus 1 times another m plus 1. I'm going to go ahead and distribute this negative 3m minus 3 and then bring down the plus 2. Let's FOIL out this m plus 1 times m plus 1. That's going to be m squared plus m plus another m plus 1 minus 3m minus 3 plus 2. Okay, so let's combine like terms. So we have an m squared. For the m's, we have 1, 2, and then take away 3. So that's going to be minus 1m. For the whole numbers, we have a 1 minus a 3 is a negative 2 plus a 2 is a 0. So that's just going to be m squared minus m. So again, it's not a number answer, but we've combined all of the like terms that we could. Okay, for this last piece of section 1.4, and that gets us caught up to where I feel more comfortable where we should be on Tuesday's class, this is leading us into what a big portion of limits is going to be for us. We're going to learn how to define a limit for a function, and then we're going to define that leads us to derivatives for calculus. So this is a big component, and I'm going to show you graphically once we get to that section what this x plus delta x means. All we care about right now is can you evaluate this. So this is, again, a binomial. So I'm going to be doing f of x plus delta x, and my function is x squared plus 3. I tried to start with an easy one. So that's blank squared plus 3 with x plus delta x getting put into the parentheses. Okay, so again, you can't just square each part. You have to write it twice and FOIL it out. Now this is where this gets a little tricky for students because you're having to distinguish two different variables. X and delta x are two different variables because delta x is change in x. So x times x is x squared. X times delta x is just an x and then a delta x. I like to put the delta x in a parentheses to distinguish that they're different variables. Then we're going to get another delta x times x. And then we're going to have delta x times delta x. So that would be delta x squared. Again, I like to keep delta x in a parenthesis so I can see that it is one variable by itself. And then I need to bring down my plus 3. I do have two like terms in the middle. So this is x squared plus 1 would be 2x delta x's plus a delta x squared and then plus 3. No other like terms. These are different because one of them has an x, one of them doesn't, and this is squared and this one's not. So this is the answer for the first part. It doesn't look very pretty, but that's it. Now this is called the difference quotient. If you did 136, you would have seen this with like x plus h minus f of x over h. We're giving h a more defined name of delta x now, and there's a reason for that. And like I said, that comes in a little bit later in the next chapter. So we're going to be looking at that this top part right here, we already did. We did f of x plus delta x. So we're going to write that answer on the top part of our fraction. Then it says do negative f of x. Well, negative f of x just means write the equation you started with, but times everything by negative 1. So it's just going to change all the signs. So we're going to write that down. And then we write all of that over delta x. If you've done this correctly, usually, especially with polynomials, you'll see that some stuff on top is going to cancel. And we have left 2x delta x plus delta x squared over delta x. If you pull a delta x out of the top, that leaves you with 2x plus a delta x. And the one you pulled out to the front can be canceled with the one on the bottom. So that just leaves me with 2x plus delta x. All right, this is the end of the video. This hopefully once you guys have watched this, you'll have all of your notes for that first packet completely filled in. And that leaves us with, like I said, I'll do one more of these at the very beginning of class, and then we'll be in 1.5 and 1.6 together. Don't forget to be working on your take-home quiz sorry, it's the take-home quiz for the 1.1 to 1.4. I gave those out in class. We are going to have that, remember, be due on Thursday of this week. So that is when those need to be finished by. And I will see you in class on Tuesday. Have a good day.